Good afternoon, and today I'd like to discuss the parallel sorting algorithm. Parallel sorting algorithm, where it is now. Okay, let me open where it is. So it is there with me. The so Majsort, where it is Majsort.c. Yeah, look at this. Normally, method will be a sequential method. How that could be? Let us examine, and then followed by how this was this kind of sorting technique was implemented. Let me explain both. Then you could understand very easily. Okay, look at this. So as far as sequential method, how this could be happened here in the sense, it is going to be took place something like this. Okay, look at this. So if you have given these elements, these are the elements which I have given to you. Let us consider these are the elements which have been given to you. Some 1, 2. Okay, some 5, 3, then 8, 9, 2, 1, some 6, and then 4. These are the elements which have been given here. For example, so this is 0. Otherwise, let me consider it as 1 here. This is 1, 2. Index elements. These are the index values what I am writing on the above. So these are index elements. Totally 8 elements are there with you. So if you are trying to execute the same by using general approach, so this is actually divide and conquer approach actually. This is a divide and conquer approach. In the general method, how this could be happen here in the sense. So first of all, it is going to identify the mid element. So mid element will be equal to first plus last divided by 2. Last divided by 2. So therefore, first plus last in the sense that is 8 plus 1, 9, 9 divided by 2, that is 4. 1 to 4 will be one subarray, and 5 to 8 will be another subarray. So therefore, it could be seen in such a way. So look at this. The array which could be contains, left array will be contains 5. So 3, 8, 9 will be subarray, and here 2, 2 comma 1 comma 6 comma 4 will be the second subarray which is going to be happen here. Okay, so in this way it has been done. And divide and conquer is always specified you. So apply division operation. So the division operation for number of times. How many number of times in the sense? So for number of elements equal to n, then followed by k, 2 power k number of division operations are supposed to be k. Recursive calls will be taken to divide the operation. So here more than one element is there here. So it is also divided into 2 parts. That is the first part will be 5 comma 3. So these are the elements which does have 5 comma 3, and 8 comma 9 is one more. So in this way, the sequential operation is going to be happen here. So here, 2 comma 1 is first sublist, and here it is 6 comma 4 will be another sublist. In this way, it has been divided. Then again, here also 2 elements, and so on. So therefore, it could be again divided into. So let me increase the size. One moment, please. Okay, this could be again divided into. So 5 is one particular element, and 3 is another element here, and here it is 8, and here it is 9. So until each and every sublist will be have single element, so it is going to be divided. So this is 6, and here it is 4. In this way, the division operation is going to be happen. When each and every sublist do have a single element, then apply for match. Apply for merge. Then how the merge is going to happen? Before going to apply the merge, so both elements will be, if you take a single element here, this is one element, and here also this is one element. So if you have only one element is there with you to sort, already it is in sorted order. Okay, ఒకే ఒక ఎలిమెంట్ మీ దగ్గర ఉన్నట్లయితే దాన్ని సార్టెడ్ కింద కన్సిడర్ చేస్తాం. సో కాబట్టి next conquer operation is being happen. How the conquer operation will be? So these two will be merged. So before going to merging, so it is also checked that whether which element is bigger and which element is next as far as the sorting is concerned. So this will be bigger, smallest value. This is the biggest value. So it is going to done here. And during this one, already these two are in sorted order. So 8 comma 9. 8 comma 9, so they can be sorted here, and here these two will be get sorted with 1 comma 2. So look at this, all these operations will be done by single processor only. All these operations will be done by single processor only. Only one processor will be took place here. Then followed by, it could be again combined by comparing each and everything. So 3 comma 5 comma 8 comma 9. These are the sorted list which is available with us, and here the sorted list will be 1 2 4 6. Two sorted lists are existed of equal size. Then again finally these two will be combined. These two will be combined, and you have to apply. So 1 2, so let me say 3 4 5 6 8 and 9. This is the actual way of running the elements in terms of so sequential operation. Sequentially, this division operation and this division operation, both the division operation must be done by single system only. I mean single process only. And this division operation here, this one, everything will be done in using single operation only. So the time which will be taken for performing this operation will be, so big O of n log n. So this is the time which is going to be took place, which is very biggest value. So because if you consider, let me analyze how this thing will be. If n equal to, for example, the 8 elements. So let us consider log n here. Log base to n, that will be equal to log base to, so 2 cube. 8 in the sense that is 2 cube. That will be equal to 3. 8 threes are 8 into 3 n log n. So that is 8 threes are 24 operations are required to perform. So just you have 8 elements with you. So when merge sort is going to be took place here. Okay, if you take some bigger values, so the complexity will be enormous will be there. So you need to check it out based on the evaluation what I have given here based on this one. Okay, so it will be taken huge amount of time. So here, so if all these, whatever the process which has been done here at this level will be allocated to one particular processor 1, and everything will be allocated at this level will be processor 2, then so 50% of work will be, 50% of complexity will be reduced. 50% of complexity will be gets reduced. At the processor 1, 5839, so 5389 will be taken into consideration for sorting, divide and conquer operation. And for processor 2, so 2164 will be taken for divide and conquer operation here. Okay, if you allocate here also one more processor or one more thread is being allocated here, something like this, then again the execution process will be gets still more or less. Then the గమనించాము. So adding of 2 arrays using 5 threads వాడుకొని చేశారు. ఒకసారి గమనించాం. సో ఈ ఆపరేషన్ ని ఇలా అంటే ఒక్కొక్క దానికి ఒక్కొక్క థ్రెడ్ ని ఇన్వోక్ చేసినట్లయితే, so every thread is working at parallel, so that everything will be taken just 1 unit of time, so that number of elements will be 8. So 8 units of time to be sort the given list of elements using merge sort if everything will be done in parallel. Okay, in parallel if everything will be done, so that could be the time complexity. So how that could be done? Let us have a look. So here, where is the main? Yeah. So here I have taken n number of elements, n equal to 10 number of elements, and this double start or stop. Why I have taken this one here is how much time it has been consumed. ఎంత time consumed దాని కోసం తీసుకున్నాను. So data of maximum time. So here you could consider maximum size is 10 here. So I have taken maximum size as 10. Yeah, maximum size. So we have taken 10 elements at random, and I have displayed before sorting what are the things here, and then we would like to get the time, how much time it is going to taken into consideration before going to start the parallel algorithm. So here pragma OMP parallel has been taken. So pragma OMP single, only one particular thing is being taken into consideration. Now here many sort of the things will be taken into consideration. After completion of this operation, then I have to stop the watch, then print out the data and how much time it has been taken to sort the, only for sorting right away from here to here I have taken into consideration. And here merge sort, how the merge sort is being. So look at this. This is merge sort. In merge sort, so look at this task 1. So first private, okay, task 2 another first private, and finally two different types of threads have been taken. First thread will be n by 2 to temporary. Okay, second will be x plus n by 2 to n minus n by 2 number of elements. That is first element to 50%. First 50% elements will be given for first preservative or first private task, and the second private task will be taken for so n by 2 plus 1 to the last, to the last. So therefore we have been taken after completion of this one. So wait for some time to complete the sort operation by these two, and then operate merge operation. Okay, so this could be happen here, and here this is actually the merge operation here. So I believe that you have some kind of idea what is merge operation with you. So if you don't, so I'd like to suggest you to read out something with Sattar Sahani, Horowitz, and Rajashekaran, fundamentals of algorithms. Please go through that particular book and you could get the proper idea. Okay. So here this merge operation will be done in such a way. So this merge operation is common for any merge sort algorithm here. So merge sort algorithm is always common. How this could be done here in the sense. So I'd like to show you. Here it is. Much disturbance is there, so that is why I just put into all of you muted me. Okay, let me show you. In designs of algorithms, we could get. I have a presentation which was given to the people, third year people. So if you have any questions, then I'll forward this one to you. Just wait for one. Wait for one. Divide and conquer method. Yeah, what is this? Bind sh. Yeah, midsort will be. Yeah, this is midsort and followed by midsort. Look at this. So this is the way of doing merging. So what the expectation here is? The expectation is this whole process will be taken by one thread 1, and this whole process will be taken care by another thread 2. Okay, so sometimes this particular side we have many elements, when compared to second side. First side కొంచెం ఎక్కువ ఎలిమెంట్స్ ఉన్నాయి, సెకండ్ సైడ్ తక్కువ ఎలిమెంట్స్ ఉన్నాయి. కాబట్టి ఇది ప్రాసెస్ ఫినిష్ చేసేంత వరకు వెయిట్ చేయాలి. అండ్ అల్గోరిథం విల్ బి సీమ్స్, ఇక్కడ వచ్చేసి మెర్జింగ్ ఇచ్చామండి, మెర్జ్ ఆపరేషన్ ఇచ్చాము ఇక్కడ. We have given merge operation. Look at this. This is the algorithm. దీంట్లో ఏం జరుగుతూ ఉంటుంది, ఈ అల్గోరిథంలో ఇక్కడ మనకి ఏం జరుగుతూ ఉంటుందో ఒకసారి అబ్జర్వ్ చేద్దాం. ఏం జరుగుతుందో ఒకసారి అబ్జర్వ్ చేద్దాం. So let me move this particular stuff towards out. So merge operation ఒకసారి గమనించండి ఇక్కడ. Try to observe the merge operation. అంటే రెండు సబ్ లిస్టులు వచ్చేసిన తర్వాత, రెండు సబ్ లిస్టులు వచ్చేసిన తర్వాత దీన్ని మెర్జ్ ఆపరేషన్ అప్లై చేయాల్సి ఉంటుంది. సో లుక్ ఎట్ దిస్. దిస్ ఈస్ ఫస్ట్ సబ్ లిస్ట్ విచ్ ఈస్ బీయింగ్ విత్ us. సో ఏ టు లో వరకు ఒకటి, అంటే ఏ లో మిడ్ వరకు ఒకటి, ఆ తర్వాత ఏ మిడ్ హై వరకు రెండవది. ఓకే, సో అంటే ఇలా డివైడ్ చేసినప్పుడు ఈ డివిజన్ లో ఫర్ ఎగ్జాంపుల్ ఇట్లా డివైడ్ చేశారనుకోండి, ఈ ఎలిమెంట్స్ మొత్తం కూడాను ఫస్ట్ సబ్ లిస్ట్, సో ఈ ఎలిమెంట్స్ మొత్తం కూడాను సెకండ్ సబ్ లిస్ట్, ఈ టైప్ లో ఉన్నట్లు లెక్క. సో అంటే వైల్ k less than or equal to mid and j less than or equal to high, ఇంతవరకు వచ్చేంతవరకు ఈ వాల్యూస్ మొత్తం కూడా యాడ్ చేసుకుంటా, ఐ మీన్ ఒక్కొక్క ఎలిమెంట్ తీసుకొని కంపేర్ చేసుకుంటూ ఏది పెద్దది ఏది చిన్నది డిసైడ్ చేసి దాని ప్రకారం మధ్య చేస్తాం. అలా మధ్య చేయడం మొత్తం అయిపోయిన తర్వాత దట్ వీ హ్యావ్ టు కాపీ ఎవ్రీథింగ్ టు ది ఒరిజినల్ లిస్ట్ హియర్. ఇంకొక లిస్ట్ కి, మన ఒరిజినల్ లిస్ట్ ఏకి ఫార్వర్డ్ చేస్తాం దీన్ని మొత్తం. ఇది జరిగేది ఇక్కడ. ఈ ఆపరేషన్ ని నెంబర్ ఆఫ్ థ్రెడ్స్ వాడుకొని చేస్తే ఎలా ఉంటుంది అనేది, ఇది నెంబర్ ఆఫ్ థ్రెడ్స్ ఆపరేషన్ అప్లై చేస్తే ఎలా ఉంటుంది అనేది ఈ పర్టికులర్ థింగ్ హియర్. లెట్ మీ ఎగ్జిక్యూట్ ఫర్ ఎ వైల్ and you will see. And open this particular command in administrative mode. You have to open this particular thing. So here D column. MinGW column. Open and cd min_gw cd bin. Okay, let me compile this one first. So the program name is mergesort. Okay, G++. So hyphen, a flag is there, F open mp followed by mergestort.c hyphen go exec. No errors are there. Then you have to execute exec. So 10 elements to the array. Let me take these elements: 9, 8, 7, 6, 5, 4, 3, 2, 1, and then finally 0. Time will be with no time. It has been taken. It has been validated. Okay. మరొకసారి రన్ చేద్దాం. టైం కొంచెం ఎక్సెసివ్ వస్తుందని చూద్దాం. సో 10 elements: 1, 9, 2, 8, 3, 7, 6, 4, 5, 0. Now you can see this is the time which was taken. Okay, milliseconds, 0.00. So 10 power minus 9 has been taken. Okay, one more time. Let me run one more time. So let us take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Already sorted order or reverse order. If you are supposed to give, nothing is, no time has been taken. If random order will be given, then obviously time will be consumed. So 5, 2. Now time will be taken if you are supposed to give at random order. At random order, it will be consumed some particular time. If you are supposed to give, so in sorted order, no time. So within no time, everything will be taken into consideration. If it is in reverse order, also no time. Okay? Continuously, it has been done here. So therefore, in this way, you have to take into consideration and implement mergesort using. Here, I'd like to send this one. I'd like to copy and send this one to you. Immediately, I'd like to forward this one to you. Please execute. execute through your machines. Try to execute through your machines immediately. Okay, so here it is. With sorting using OpenMP kind of thing here. Please. Okay, so please go and check out this one. Yeah, that's what. Only this particular program has been prepared by me. The rest of the things are not prepared. Okay, tomorrow, day after tomorrow, I mean by Monday, we'll consider one more program that is what are the problems still all have with us? Ranking algorithm. One more algorithm is ranking. Second algorithm is second is sorting, ranking, searching, traversal. Okay, so I'd like to take all this, probably ranking and searching, followed by traversals also. Traversals also finished by Monday. By Saturday, by prefix sum also finished by next week. Next week, unit number 3 will be gets over. Okay, next week is complete చేద్దాం. Okay, let me take your attendance. Just wait for a while.